Why do decision trees outperform neural networks on tabular data? Imagine trying to find your way through a maze. Some paths are clear, but others are tricky and irregular. Now think about how computers learn from data. Different algorithms navigate these paths in different ways. Today, we're exploring why decision trees often do better than neural networks when working with tabular data. Tabular data is like a spreadsheet with rows and columns. It contains a mix of numbers and categories, often with complex patterns that don't follow smooth curves. Decision trees handle this kind of data naturally. They split the data into smaller parts based on feature thresholds, like asking yes or no questions. Each split aims to reduce uncertainty or impurity, making it easier to classify or predict. Because of this, decision trees can easily capture irregular patterns and handle different types of data without much fuss. Neural networks, on the other hand, are designed to learn smooth, continuous functions. They work well with images, speech, and text, where data changes gradually. But when it comes to tabular data, neural networks often struggle. They assume the data is more uniform and may need lots of tuning to work well. They also prefer large datasets to learn effectively, which isn't always practical with medium-sized tabular data. Another reason decision trees shine is their ability to handle missing data and categorical variables directly. Neural networks usually need extra steps to encode categories or fill in gaps, which can introduce errors or complexity. Decision trees don't require special hardware either. They train quickly and don't need graphics processing units, making them more accessible for many applications. In fields like finance, healthcare, and business analytics, decision trees are popular because they give clear explanations for their decisions. This transparency is important when decisions impact people's lives. Neural networks, while powerful, often act as a black box, making it hard to understand how they arrive at a conclusion. Overall, decision trees match the structure of tabular data better. They split data based on features in a way that captures irregularities and mixed types naturally. They are easier to tune, faster to train, and more interpretable. Neural networks excel in unstructured data like images and text but are less suited for the messy, diverse nature of tabular data. That's why, for many practical tasks involving spreadsheets and databases, decision trees remain as the top choice. Just like how tools like ChatGPT, DALL-E, and Midjourney are tailored for text and images, decision trees are specially suited for the kind of data we see in everyday business and science.